remember you're carrying that through. Okay, so 6 moles per liter. How many moles would exist in 3 liters? So again, this is 2 significant figures of the solution. So this time we know the concentration, this equals C, and we know the volume, and it's already in liters, so we don't need to convert it, is V. What we're missing is N, so we're finding moles. If you are somebody who likes the magic triangle method for rearranging equations, you can draw your little magical triangle. C equals N over V. It would look like this, so C, N, and V. If you're missing N in this case, you would cover it up, is C times V. So N equals C times V. C, we know, is 6.0 moles per liter, times V is 3.0 liters. Liters divided by liters cancel each other out. Left with 18, we get 2 sig figs moles of hydrochloric acid. That's what the question was about. So therefore, there would be 18 moles of HCl in the solution. All right, number 3. How many grams of potassium nitrate are required in order to make exactly 1.5 liters, so 1,500 milliliters, of a 3 molar solution? So this is, again, moles per liter. This is in milliliters. We have to convert it into liters, so we may as well just do that first. So 1,500 milliliters times, we want to get rid of milliliters, so that goes on the bottom. Liters goes on the top. There's 1,000 milliliters in 1 liter. Mils divided by mils cancel each other out. 1,500 divided by 1,000 times 1 is 1.5 liters. This is 2 sig figs. This is also 2 sig figs, so our answer will get 2 sig figs. We have liters now, so that's our volume component, V. Concentration we also know, so C was our 3.0 moles per liter. But we're not actually finding N in this equation, so it asked us for grams. But if we know moles, we can always get to grams using molar mass. So to do this question, we're also going to need the molar mass of potassium nitrate. So let's calculate that. Hopefully you guys remember after the long break how to calculate molar mass. So molar mass of potassium nitrate is the molar mass of potassium, so 39.098, plus 1 nitrogen, 14.007, plus 3 times the molar mass of oxygen, 15.999, is 101.102 grams per mole. All right, so we have volume, 1.5 liters. We have concentration, 3.0 moles per liter. Moles per liter, this is a conversion factor. It's got a different unit on the top and a different unit on the bottom. So we can use it to get from liters into moles. Then we have another conversion factor here, which is molarity, or molar mass, pardon me, which helps us go from moles to grams. So this is going to be a 2-step question to find the grams of potassium nitrate. We start with 1.5 liters times, we want to get rid of liters, liters go on the bottom. Middle step is always moles. We always convert everything into moles, so moles go on the top. Moles per liter is concentration. It's 3.0 moles per 1 liter. Remember, anytime we have a unit like this, it's the same as this. There's a little imaginary 1 that sits beside that liter symbol. So Liters divided by liters will cancel out. We'll be left in moles. We don't want moles though. We have to keep going. We want out of moles, so moles go on the bottom, and we want grams. So grams go on the top. Our number that's grams per mole, molar mass. So 101.102 grams per 1 mole. Moles divided by moles. Now we'll be left with an answer in grams. Throw this into your calculator. 1.5 times 3 divided by 1 times 101.102 divided by 1 is going to give you 454.959 grams. We only get 2 significant figures, so 2 sig figs. That rounds us to 4.5 times 10 to the power of 2 grams of KNO3, or 450 grams of KNO3, depending on if you like scientific notation or not. Therefore, it asks us how many grams are required. We're going to answer the question. 4.5 times 10 to the power of 2 grams of potassium nitrate is needed to make the solution. Okay, one more. Example number 4. What is the molar concentration, so this time we're finding concentration, of a solution prepared by dissolving 0.35 grams of silver nitrate in water to make 65 milliliters of solution? So we have a volume and we have a mass. But remember, we don't normally have concentration measured in grams per milliliter. It needs to be in moles per liter. So we have to convert this into liters, and we have to get from grams to moles. To get from grams to moles, we know that we're going to need molar mass. So let's do that first. Molar mass, curly M, for silver nitrate, AgNO3, is 1 silver, which is 107.868, plus 1 nitrogen, 14.007, plus 3 oxygens, 3 times 15.999, is going to give us 169.872 grams per mole. So there's our molar mass so that we can get from grams into moles. Let's do that step first. So converting from grams to moles, 0.35 grams of silver nitrate, AgNO3, times, we want to get rid of grams and we want to get into moles. Molar mass is grams per mole, 169.872 grams per 1 mole. Grams divided by grams equals 0.00206 moles of AgNO3. So now we have moles, that's N. And we have volume here, which we need to convert into liters so that we can use our C equals N over V. Concentration, which is what it's asking us, is moles of solute. We've calculated that, divided by volume of solvent. To find V, we take 65 milliliters times, we want to get rid of milliliters, into liters, 1,000 milliliters in a liter. Mils divided by mils gives us 0.065 liters. So now we have both of these numbers. Our moles, 0.00206 moles of AgNO3 divided by 0.065 liters of water is going to give us 0.0317 moles per liter. We get to keep 2 significant figures. Always keep a few extra until the very end, otherwise your rounding will be off. 0.032 moles per liter. Therefore, the concentration of the solution 0.032 moles per liter, or capital M. So there's some homework questions here for you to try that will use that C equals N over B,